Hello students, this is the Computer Science GCSE Edexcel Paper 1 2020 spec, and I'm going to go through as practice before the GCSEs so you can even help you revise. Make sure you answer every question and look for the command words and be really legible and clear with your answers. Computers, the CPU contains a number of components. So when we're dealing with a fetch, decode, execute, we're looking at buses. There are 3 different buses. Data is bidirectional, and that will carry instructions. So data, and then the location is like an address. So just remember, like how to find somebody, it's an address. That's the best way. Location is your address, and then the control is the harder one to remember. For read signal, identify the component inside. So registers are really fast acting bits of memory which are inside the CPU. The clock is outside the CPU. The ALU is inside the CPU. The ALU is in there, and it's like a giant calculator. Well, I say giant, it's not. It's a calculator, arithmetic logic unit, and the clock is outside. And main memory, RAM, is also outside. Algorithms can be written in high-level languages. Okay, so the only 2 languages which are classed as low level are assembly language and machine code, which is just binary, zeros and ones. State what a high-level code is translated to. So those. Best option, machine code. You could probably put binary here and get the mark. You could also put an exe if you're compiling directly to an executable, but machine code is the best answer. It's just the zeros and ones that are specific to the manufacturer. Assembly language is human readable, but it still has to go to that machine code. It's really close to the hardware, and it's a very powerful language, but you still have to go from assembly language to machine code. State 2 methods of source load translation. Well, there are 3 in total. Compiler, to compile, interpret by an interpreter, interpret, so interpreter, a bit of a mouthful, compile, and then there are also assemblers which assemble. So there are only 3 translators possible there. They'll definitely allow all of those different iterations of spelling. Identify the feature of an optical disc. Well, it's reflective. That's a nice and easy one. If you've got a DVD or a Blu-ray or CD, the laser reflects, and you've got the pits and lands which represent the zeros and ones. Define the term embedded system. Right, so just be careful here because you don't want to lose marks. Forms part of a larger system or device, or single dedicated use. If you can't remember what an embedded system is, think of your washing machine. Right? It's not a general purpose computer. You're not going to be running programs from it, but it's got a limited CPU, limited RAM. They're generally smaller, lower cost, lower power. Embedded systems are all over your house right now. A code review is carried out by programmer of an automated system. Both cost money, right? Compile the table with one disadvantage of each by a programmer or an automated system. So automated systems might not identify all issues. Okay, only well-known problems. They might only be able to get so it'll only be programmed to find certain things, and it won't be sort of innovative enough to check other things. A programmer could also introduce human error, bias, extra labor, of course, and needs more experience, and time, additional time. I think that would be enough to get 2 marks easy. Identify the purpose of defragmentation software. Defragmentation is only done on HDDs, magnetic storage devices, okay, not SSDs, because it can actually damage them. SSDs have a finite read and write amount that you can actually read and write to before they die. So in terms of secondary storage, it's not appropriate to defrag on optical systems or SSDs. It's only magnetic storage. What is the purpose of it? The purpose of it is, where you might trip up is, you might think it's freeing up space. It doesn't really free up space. It just moves all those blocks to be together. So if you've got like different blocks A, B, C, and D, all related to a file, and they've been spread across the drive in different places, then it sticks them all together, so they're all together and all the blank space together. So for organizing data is the best one there. And obviously when you're doing this, use a cross. One function of a operating system is to manage processes. Describe one way the operating system can make sure each process can use the CPU. So you've got lots of algorithms like round robin, so equal time, priority based, or first come first serve. You could talk about those. A scheduler controls the processes. So a scheduler algorithm controls processes. So they're held in a queue, a data structure, and they're held in order of priority. Okay, so lots of things you could put there. The scheduler algorithm is the main one you need there. Give one other function. Well, there's so many you could choose. Easiest one to remember would be file management. I think that would probably be the easiest one to use and safe bet. But you could also have share, or let's just keep with management. Peripherals. If you're unsure what a peripheral is, just think of a printer. Okay, a printer. If you're printing something out, you can share it amongst different computers. The operating system allows you to do that. You could talk about user interfaces as well, UIs. Complete the diagram. Okay, so TCP/IP model. The best way to remember this is you start off with an application. So it could be, say, Outlook. Just think you're writing an email to yourself. Just have that scenario in your head. And what do? You've made your email. And then what you need to do is chop it up. You need to chop that email up into packets that will get sent across, and then finally, once all the IP addresses have been matched and the sort of routers have done their job, you'll get the data, the zeros and ones, gone into, let's say if it's copper wire, it'll be electrical pulses, or if it's fiber optic, it'll be light waves. And then all of that happens again reverse. So it'll be link, internet, transport, application, so that you can receive the email. Somebody else can receive the email. It goes in reverse. So you think of a scenario like you're on an application, you chop it up, use the transport to send it, and then the internet layer is dealing with the IP addresses, and then finally the link layer that says, okay, how do I actually send this data? Name the network topology that uses terminators. So terminators, either end, it's bus. You've got to just memorize those three: mesh, star, and bus. So bus is the answer there. Identify the reason computers are connected to it. Okay, right, the reason. Bit of a strange question. The only one I can really see is to share peripherals, like a printer, like I said earlier. If you want to share that peripheral, if you're on a network, that would be the best option. Weird question. State the network protocol used to request a web page, HTTP or HTTPS, secure. When Tim Berners-Lee set up those protocols for the World Wide Web that runs on top of the internet, the physical infrastructure, he put the HTTP protocol in place. Hypertext Transfer Protocol. Explain one benefit of a user for using IMAP to access emails. Well, IMAP saves access from multiple devices. So you've got your phone, you've got your laptop, you've got your desktop. Okay, so you can access your email from all of those because the emails are on a server. Now POP3, on the other hand, downloads to a device and deletes from the server. So most people don't use POP3 anymore. Internet bandwidth and is good enough, and people have sort of 5G, 4G, and they can have cloud services that hold all their email. It's far more convenient. But that's the other protocol. Emails can be accessed through a web browser, for example. Let's have a look at the next one. A factory has 2 file servers installed in an office. A closed CCTV monitors the factory. Explain one other method of physical security. Oh, that's a bit of a strange question. Physical security. Well, literally just think of a situation like maybe in a school where if you've got a classroom and you've got the door, can only the teacher access that? Because I know a lot in my school, I have to have a key card or lanyard, and I have to tap that with RFID to get in the door. You could also talk about biometrics, but if you've got your thumbprint or something like that, or retina, that could prevent. Or also, movement sensors. If you've got an alarm, for movement sensor, security lights, alarms. You could literally have a fence as a security to stop people getting in. I think that's probably enough there. Like you could have like ID tag, ID card to access. I would probably go with that angle. I think that's the best option to answer that question. Network speed is the current rate of data measured in bits per second. That's important, not bytes. You've got to not be trapped up there. Define the term bandwidth. Bandwidth is like the max, I'm just abbreviating here, volume of data that can be transmitted at any, well, not any, at 1 second. Yeah, in 1 second. So I'll put in 1 second because it's, you know, megabits per second. Think of it as sort of a big cake, and if every user is taking a slice of that bandwidth from whatever you've got into your house. So yeah, I think that's the best option, to have that per second, and it's the maximum volume, full capacity. High-speed fiber optic cables from the internet backbone, they most certainly do. They also have an 80-kilometer range, which is far better than 100 meters for copper. Okay. Describe how a router enables data to arrive at its destination. So a router reads destination and recipient. Sorry, destination or recipient, they're the same thing, aren't they? Recipient, IP address in each packet. So if you had a file like I don't know, a picture of a sort of beach with a palm tree and a sun, a little deck chair, that will get chopped up into little pieces, and each of those could be a packet. They're probably likely to be under 64 kilobytes. So lots of packets, and each of those packets is going to have a metadata according to where it came from, where it's going, what the order is, so that it can be rearranged at the other side. And then routers use a routing table, and they decide the best course, the best way to travel. If there's a congested route, if there's a mast down or something, you know, if there's a mast outside that's broken, it will reroute it. And it also informs other routers of any issues too. The best sort of way of going around. It's a bit like having traffic information on your radio in the car. Let's have a look at the next question. Computer worms are a type of malware. Describe one way that a worm can move from machine to machine. Well, worms, unlike viruses, worms make copies of themselves, okay, and then they send to like an email contact list or something like that. Very insidious. They spread through themselves, and often the users are unwittingly, they don't even know what's going on. So the important thing here is they self-replicate, whereas a virus, on the other hand, needs a host file, like a PDF or something like that. It needs a host file in order to work. The source code of a software application is automatically copyrighted. State one other method of intellectual property protection to control who can use. Okay, so you can license software to other people to use. Licensing, it's possible to do that. If it's if it's something hardware related and innovation, obviously you use patents. Computer programs control some airplane landings. Explain one reason computers are not capable of safely controlling all airplanes. So it's an explain question, command word. We want to have a linked description. So we could say the landing program might crash because, and this is the important thing for you want a command word, pardon me, of insufficient data, bugs, out of date software. It could also be sensor malfunction, leading to a sensor malfunction, leading to some errors in the algorithm. I think that'd be enough for 2 marks there. Large amounts of water used for computer chips. Describe one way this impacts the environment. Well, the easiest option is that the land, and this does happen, rivers will be polluted if, because we want to link this together, if contaminated is released, and this happens a lot. So you get a mark for each of these parts, but you have to link it together. And also it's very typical. These data centers, you've got these huge buildings that hold these data centers, and then nearby neighboring towns, they have terrible water pressure, arid sort of conditions around there for crops, because all the water is being sucked into the data centers for cooling. So not just about wastewater, but also just destroying the local agriculture and homes and businesses. It happens a lot, unfortunately. There are ethical and legal issues with the collection and use of personal data. Complete the table with the ethical or legal issue. Okay, an online learning platform publishes data about how students answer questions. So this is a consent issue. This is about giving consent. A teacher uses another teacher's login to change students' grades. What is the issue here? Well, it's misuse. It's computer misuse, isn't it? You could probably go even as far to say as hacking, but it's more about misuse. That's definitely a mark. A school displays closed circuit television CCTV screens in a public area. Well, this is a privacy issue. Privacy, and also it's also related to consent. Permissions. I mean, all the students have got to have said, I permit that to happen, for that to be allowed to happen. Schools often have AUPs, user agreement policies, where they might have that, is to parents have to sign whether they allow their student, their daughter or son, to be in photos or newsletter, or to be publicly seen on media. Programmers use trace tables with algorithms. Explain the purpose of a trace table. Okay. So if you saw that 2022 paper that I did earlier, that was a really good example of using a trace table. It helps to, so it's an explain, it helps programmer to visualize essentially the steps in a program. and find errors. I mean, that's really the best option, find errors, bugs, because if you go through it with certain data and trace through the algorithm, you can see, okay, will it actually produce the correct intended output? Algorithms use arrays and records to hold data, describe a record. So it's a data structure with fields, values, where each field might be a different data type. So let me just give you an example. So I might have student name as a string, then I might have their age, then I might have their ID number or something like that. And then maybe the amount of money they got on their lunch card. So it could be £5.23. So I've got a real number, real float here, integers here, strings here. And typically records are used when we're dealing with file reading and writing, and you've got comma separated values in a text file, txt. So the record might start off being a string, just a bit of English, and then we chop it up, and they're comma separated. It's often how records are implemented. But in Python, in the exam, you'll see them as Python lists, sometimes in 2D arrays, where each data type has got it. So if you've got a 2D array, it's a bit of a misnomer to say that it's. So I prefer the term 2D data structure. 2D data structure, because that could be a record in there, rather than just having an array has the same data type in there. Right, an algorithm allows users to enter a whole number. The number can be positive or negative. Okay, it's to report whether the number is odd or even. The modulus function, so it tells you to use the modulus function, returns the remainder after division. We should know that. Like, for example, if you did print 17 modulo 3, you'd get 2, because 3 times 5 is 15, 2 remainder. So, and by the way, a subprogram is these. You probably won't find it in the exam, but there it is, just in case. Complete the flowchart. So here we go. Right, so we always want to have the terminator. They've given it to us. They've probably given us the end as well. And notice how they've given us the end of the arrows to remind you that that's what you need to do. So we need to get the number, and if we get the number from the user, it's a parallelogram, because we've got input or output to the system. It's not a process. Get the number, and then it's just simply a decision at the moment. Rhombus is number modulo 2 equal to 0. Okay, and it's either going to be yes, and make sure you label it yes or no, and if it's no, then we can display odd as a string. Yeah. If it's yes, we can display even. So nice easy question actually. And then both of those, they can go to our stop. A linear search algorithm can be used on both a sorted and unsorted array. Yes, just for interest, a binary search can only be done on sorted arrays in ascending order. So you can't use binary search if it's not sorted in ascending order. Describe how a linear search algorithm operates on an unsorted array. Don't get confused with a question like this. I've seen students really mess this up before. It's 4 marks, so you say four things, you describe. I mean, if you really need to, just have like a list, an array here. Let's say, let's just keep it simple. Let's just have 8, 1. I don't know. I'm just making it up here. So we've got an unsorted array, and let's say we're looking for, our target is 9. Well, what do? You simply start at the first position. Start the first position, and then iterate over each element, traversing through the array. Compare element to target value. Stop when target is reached, or stop when end of the list, and item not found. So in this case, we just literally go through all of these, check them one by one. It's linear, so think of the line. That's the way to remember. Best case scenario is we're looking for number 1 and it's right there. That's the best case scenario. Worst case scenario is we're looking for number 2 and it happens to be at the end of the list. So if that was 1,000,000 items long, then it would take us a long way. Z for zebra, if we were looking for that, and it happened to be at the end. Algorithms control physical devices using logical operators. Okay. A security system turns on a floodlight when the sunlight falls below a certain level and a movement sensor is activated. So complete the truth table. It's really simple, but you need to remember what the truth tables are. So I'm going to put and, or, and not. Those are the 3 you need to learn for GCSE Edexcel. You either have A and B, and then output. A, B, out, A, B, output. So here it's it's a negator. So it's either just the opposite. Negator is opposite. Okay, so we'll just make the opposite of whatever it was. For OR, you need only one side to be true. So 0, 0 is 0, but if you've got 0, 1, that's true, so 1. That's true, and 1, 1 is true. And you need both of them to be true for it to go true at the end. Sorry, 1, 0, 0, 1, 0, 0, all of this is 0. Okay, so this is AND. So you simply put your trace table in, all the different options, and you just need to make sure you remember what an AND is. Next question. A group of students are working together on a single maze game. The arrow keys control the character. When the character reaches the end of the maze without touching a wall, a happy sound is played. The game also displays a score. Okay, so we've got a sound and score. Discuss the use of decomposition and abstraction in developing this game. So you need to remember what they are. So decomposition is breaking down a problem or task into smaller parts. Okay, don't overthink that. Abstraction is the process of removing unnecessary on two ends necessary detail. Okay, think of the London Underground map. You know, if you've got a London Underground map, there's a lot of detail actually going on the trains and underground. We don't need to know all of that. If you've got the Circle Line, you don't need to see all the little actual wiggly, windy bits that actually happen. It's just abstracted to be roughly going around in a uniform way. So benefits for this, it's easier to solve. Yeah, I'm just going to abbreviate here. Solve smaller problems. It's easier, such as touching the wall or the score system, rather than just tackling everything in one go. Different parts of the program can be shared between the class to speed up development. Delegate tasks to others. Just like, think of a manager. What does a manager do? They'll tell you do this, and you do this. What else can we do? All the pieces, movement, the score, smaller solutions can be combined to find the larger solution with fewer errors. And the individual parts of a program can be ignored by the group of students working on the code. So that's where abstraction comes into place. If one group of students is working on the score system, they don't need to worry about maybe the sound, right? They probably don't need to worry about who's doing the sound. And what else could you say? I think it'd be good to note that sub-programs are both decompositions and abstractions. They're both, because you don't need to know how, say, if you've got, I don't know, math.py, right? If you're trying to get the math.py, you don't need to know how it's doing that. You don't need to know how the input statement is actually working, other than the fact that when you use it, it does its job. It does what you expect it to do. So it hides the complexity of it. I mean, there's a whole load of Python code behind the scenes that deal with all of those things, but you don't need to know you don't need to worry about that. And also they can be used to sort of break problems down into smaller parts. Like, I wouldn't have to work out a really difficult version of pi or figure out how to do square rooting or something like that if I can just call upon a subprogram that can do it for me, or a method. So subprograms are both abstractions and decompositions in that regard. Data. Describe one effect of using lossy compression to reduce the file size. So lossy is to do with, if you've got MP3 or JPEG, they're typical lossy formats because you cannot recover the information. Information cannot be restored. Okay, it's gone. If you've got like a raw file from a camera, and you've got your DSLR, and you've taken a nice new picture on it, then let's say it's, I don't know, 40 megabytes. When you've gone to a JPEG that's like, I don't know, 3 megabytes, you've lost a lot of information, less than a tenth. You can never go back to that point. You can never go back here from a JPEG. It's gone. So that's a lossy. Lossless is when you haven't lost any information. Here is an original image. There is one bit available to represent each pixel. Why the image cannot be accurately represented. So if you've got one bit, literally a 0 or a 1, you can only have, like, say, black or white, and we've got grey. So we would need at least 2 bits of information here. 2 to the power 0. You know, we need at least 2 bits to store this information in there. In here, we would be able to have 2 and 3, and up to 0 to 3, which is four colours. You could have two shades of grey, white, and a black if you're in a 2-bit image. Because you can't store, only 1 bit can have 2 values. All right, so that would be enough to answer that question. Shifts, okay, arithmetic shifts are always causing problems for students. A logical shift is performed on a pattern. An arithmetic right shift is performed on the same original pattern. Describe why the results will be different. Well, with arithmetic shift right, we are dividing, but we keeps MSB the same, and fills gaps with value of MSB. Whereas logical shifts right fill gaps with a 0. Okay, so let's just do an example. It's best to know what the MSB is and least significant bit. So if we've got, say, I don't know, let's just do 38. We'll do a bit of choose complement while we're at it. So how do we represent that? We do positive 38 in binary. So 128, 64, 32, 16. We don't need that, we don't need that, we do need that, we don't want that. We've just got 6 left, so we need those 2. That's going to be 38. Then what we want to do is flip the bits. And add 1. So if we're adding 1 to this, then we're putting a 0 here and adding 1 here. So because if you've got 1, 2, 3, 4, 1 is 0, 1, 2 is that, 3 is that, and 4 is that. It's the best way to remember. So 1, 1, 0, 1, 1, 0, 1, 0. Let's just check. So we've got now a minus value here. Minus 128 plus 64 is minus 64. Minus 64 plus 16 is 48. Plus the 8 is 40. Plus the 2 is minus 38. Okay, so we've proved that we have a minus 38. So if we've got 1, 1, 0, 1, 1, 0, 1, 0, and we want to shift to the right, shift right, divide by 2, essentially just 1 to the right, then what we need to do, what do we expect that to be? We expect that to be minus 38 divided by 2. That's what we would expect it to be, right? So if we have to keep the value of the MSB, and we move everything this way. So we're going to maintain that minus 128, but we've got a gap. Then this goes over here, it goes over here, 1, 1, 0, 1, and this 0 gets chopped away. Now we haven't lost any information, so we can do this. But we have to maintain the value of the MSB, so we have to fill the gap with the MSB here. So what do we have? Minus 128 plus 64 is minus 64, plus 32 is minus 32, plus 8 is minus 24, then plus 4 is minus 20, and then minus 19, which is minus 38 divided by 2. So we know that we've done it correctly. That was a bit of overkill there, but you know, I'm sure that if you're watching this, you're revising for your GCSE, and doing 2's complement wouldn't hurt. Convert the binary pattern to denary, really nice and easy. There should be no problems here. Just literally write it out. 64, 32, 16, 8, 4, 2, 1. Nobody should be getting this one wrong at all. 64 plus 2, 66. Okay. And then convert the pattern here to hexadecimal. The trick here is to look at each nibble and then split them up. 8, 4, 2, 1, 8, 4, 2, 1, and then you just simply count them up. So 4 and 1 is a 5, 8, 2 is 11. Now in hexadecimal, 1 to 9 is normal. A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, F equals 15. So you've got 0 to 15, 16 values. So that would be 5B. That works for any number. Like, as long as you can, if you can get to binary and then you can split it into nibbles, you can always get your hexadecimal. Data storage is measured in bits and bytes. State the number of unique values that can be represented in 6 bits. Well, literally just write. If you're getting stuck with things like this, write it out. Or you can do 2 to the power of 6, like 2 times 2 times 2 times 2 times 2 times 2, right? Otherwise, just have 1, 2, 4, 8, 16, 32. So what can you have? The next value is 64. All of these would be the next value minus 1. So the biggest positive number we can have is 63, but we also have 0. So if we have 0 to 63, we have 64 unique patterns available. So the easiest way is just 2 to the power 6. If you wrote 2 to the power 6, you'll get the mark. A file format uses 100 by 600 table of 32-bit integers. The file uses 1 kebibyte of additional data. Construct an expression to show the number of bytes of storage needed to store the file. Right, okay, so if it was a bitmap, for example, it's width times height times bit depth. So that would be 100 times 600 times 32. So that's our numerator, or at least part of it done. But those are going to be bits, so we want to make sure that we're getting bytes. There are 8 bits. 8 bits equals 1 byte. So what we're doing up there, this is a byte. So divide that by 8. And then we've got a kebibyte of data. A kebibyte is 1024, 2 to the power of 10. Yeah, so if you did your 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and then 1024, 2 to the power of 10. Okay. You've got to remember what a kebibyte is. Okay, that equals a kebibyte. 1024 to the power of 2 is a mebibyte, and then you can just go up to the power of 3 accordingly, right? You've got to memorize that for your exam. So we just need to add that to our file expression. Don't need to work it out. You won't have a calculator. This is a pretty awkward question. An analog sound is represented in digital form. The sound is 1 second long and is sampled. So frequency is in hertz. Okay, and it is in seconds. So 10 hertz. Normally, for a CD, it's 44.1 kilohertz. Yeah. So normally for audio, it's 16-bit stereo. Yeah. So sometimes audio questions go around those lines, but in this case, it's okay. We've got 10 hertz with very, very low sample rate. Digital representation has a bit depth of 5. Fine. So, and it's stored in 2's complement. Well, we've already covered 2's complement today. So what is this? If that's minus, so 1, 2, 4, and 8. If that's minus 16, then minus 16 plus 8 is minus 8, minus 4, minus 2, minus 1. So those equal minus 1. That's a 0. Minus 1, minus 1, minus 1, 0, 0, 1, 1, 1. So these are the MSB. So it doesn't matter how many bits your binary number has. The one on the left is, if it's in 2's complement, the one on the left is always a negative, which is confusing because Edexcel say you don't need to know about MSB values, but how could you do this question otherwise? So label the X and Y axes and label values and sample plotted X's, join them up for digital form. Right, this is a pretty awkward question. So over here we have amplitude, and it's only going to go up to +1, -1. Those are the only gradations we're talking about here. And then time is over this way. And we've got 10 hertz, so 10 samples essentially. 10. So what we'd be expecting is, I'll start off from here. The first one is a 0, then it's -1. There were a whole bunch of -1s, weren't there? And then we went back up to, so 1, 2, 3, 4, 2 zeros, and then 1, 1, 1. Like that. I think that'll be enough. That's 1 second. 1 second. So if your frequency is literally, the interval is a space between each sample, there are only 10 per second there. So we've got over 1 second. We've just got 10 snapshots of this. Pretty awkward question, 6 marker. Hopefully you don't get something like that in your test. And that's it. Okay, good luck. I would say that was a pretty awkward question to end the test on.